How we doing, guys? Different way of doing physics here. Just trying to roll the punches, I guess. One thing I want to get you to do is watch this YouTube video. Once you've watched the YouTube video, you'll be on Zoom. So log on to Zoom, watch the YouTube video. Then after you finish the YouTube video, I want you to work the problems that I've given you. This first assignment is going to be working the problems through Physics Classroom website. I want you to just show me your work on your own sheet of paper. You're going to take a picture of it, upload it to Google, and turn it in that way, which I want you to do that by Wednesday night at midnight. And then your second assignment will be due, we'll do it on Wednesday, and I won't make it due until Sunday at midnight. So we'll kind of do the same thing on that day. So I have two separate videos for you. Beginning Unit 4, I know we talked about the car coat hanger. We'll kind of do that a little bit later on down the road. We can kind of incorporate this into it also when we talk about work and all these things. And so we're just going to go ahead and get started with Unit 4. Just kind of give us a fresh start here. Work, energy, and momentum, and its theorem. This is what we're going to look at to begin with. This probably won't take but about 10 minutes. And then the next one will probably be only 7 or 8 minutes. So with work, energy, and the energy theorem. Which of the following is not work? So we give you these different things. Pushing a stalled car, pulling a wagon, climbing stairs, falling down, or carrying a heavy backpack down the hall. If you were here, obviously we would answer these questions. But if you think about these, when you do work of some kind, work is going to be equal to force times the distance of that object. So which one of these, if we push a stalled car, it moved a distance, we did work. Pulling a wagon, it moved a distance. Climbing stairs, we moved. Falling down, we moved. But carrying a heavy backpack down the hall, the backpack itself on our back is not doing any work because essentially the backpack is really not moving. So carrying the backpack down the hall there. Okay? Next thing. We look at this as work. It depends on the force and the distance of the force that moves the object. So it depends on the force and the distance the force moves the object. You see here, with this, you've got work equals force times distance. He's putting a force on the lawnmower. It's going to move a distance. And with that, and knowing what we've got, the force is going to be equal also to the cosine of the theta. So what is the angle that we're pushing at? So that has to come into play too. So when we look at it, we want the force in the direction of the distance. So the force has got to go this direction. If the force is going that way, but the distance is going the other way, obviously it'd be counterintuitive and it would not work. So with our equation, work is equal to force times distance, and work is equal to force times distance in the cosine of theta. So what is the cosine of theta? And it'll be something that's given to you or something that we have to find as we work through some of these problems. So if you want to pause it real quick and write some of this stuff down as we go for your notes, perfectly fine with me. So work is equal to force times distance times cosine theta. Now, the unit in itself is a Newton times the meters, which is going to be equal to a joule. The joule is what we measure energy in. And with this, with it being work and with it being moving, it's got to be kinetic energy. So it's energy in itself, and we always measure energy in joules. Okay? First questions. And we'll kind of let you kind of work through it because these are really simple problems that we've got. So Marcy pulls a backpack and on wheels down the 100-meter hall. There's our distance. The 60 Newton force, there's our force, is applied at an angle of 30 degrees above the horizontal. How much work is done by Marcy? So if you were to have, we're in here in class, I go over the board, I write this stuff down, but with this right here, we don't have it. So work is equal to force times distance. So all you have to do is take the force, which is 60 newtons, times the distance, which is 100 meters, and then multiply that by that angle as they pull this backpack. They pull the backpack, which is a cosine of 30. So the cosine of 30 times our force, which is 60, times, which is 100, we should get, let me do this again, 100 times 60 times the cosine of 30, boom, and we get 5,196 joules of work. So 5,200 joules of work based off of our answer here. So pretty simple problem. Again, work equals force times distance times the cosine of theta. We keep moving on. Drew is carrying books down the 100-meter hall. How much work is Drew doing on the books? The books are what's in question. Are the books moving? I can do work equals force times distance, and it's 200 times 100. So But if we do that, 200 times the 100, we know that we've got 20,000 joules of work that Drew's doing. But how much work is being done on the books? Are the books moving? No, they're not, so the distance is going to be 0. So 200 times 100 is 20,000 times 0, the work is still 0. Or if you put in your calculator, the cosine of this angle would be 90 degrees. That's 0. Cosine of 90 is 0, so 0 times 200 times 100 obviously is 0. So the work that is done is 0 joules because the books are not moving. Here, you carry some books while walking down the stairs at a height of 2 meters and a length of 3 meters. How much work did you do? With this one, we're going down. If the books were up, they were at 90. If the other ones are going down, our angle here has to be 180. So our force is 200 newtons. Our height is going to be 2 meters and the length of, while walking downstairs at a height of 2 meters and a length of 3 meters, how much work did you do? So simply, all you have to do, obviously now we've got 2 times 3, this gives us 6 times 200, and you're going to get your answer. Cosine of 180, which gives us a negative number. If I take the cosine of 180, and that is negative 1 times 200 times, you get negative 1200, negative 400 joules, I'm sorry. So you get negative 400 joules there for us to be able to do that. So 200 times the height being 2, 180, cosine of it, negative 1, times the 400, you get negative 400. So the height is what's coming into play here, not necessarily the length. And that's my fault just a while ago when I said multiply the two together. You don't have to do that because you're looking at the height of the stairs. How much work did you do with the books? Because the books are going down. And that's my fault a while ago, like I said. So 200 is the newtons of force times the 2 meters, which is 400. Take the angle, the cosine of 180, which is going to be negative 1, gives you negative 400 joules. So we have another question here. Suitcase is hanging straight down from your hand as you ride an escalator. Your hand exerts a force on the suitcase and the force does the work. Which one of the following is correct? Is the work negative? Is the work negative when you ride up and positive when you ride down? Or is the work positive when you go up and negative when you go down? Or is the work just positive and the W just negative? So if we look at this and we go back to that last question, it's hanging straight down from your hand as you ride an escalator. Your hand exerts a force on the suitcase and the force does the work. Remember, the force and the distance have to act in the same direction. So if the force and the distance are acting in the same direction, B would have to be the correct answer. The work is going to be positive as you go up, negative as you ride down. So we get that right there. Okay? To do work, we know we have to have a force. So work equals force times distance. So if we have to find the force, we know we find force. Our force is equals mass times acceleration. So work by net force gives an object some type of acceleration. It has to have acceleration. Again, it has to move. All right, the velocity is going to change if we have an acceleration. It could be positive, it could be negative, like we've talked about with velocity. You got to have a direction. Okay? Energy, we know, is the ability to do work. When we talk about energy, kinetic energy is energy due to motion. Things that you guys have heard before. It's very simple. Something in motion hits an object, it will move some type of distance. It's got to move somewhere. That energy has to be transferred. We know kinetic energy is equal to 1/2 mv squared, something you learned back in the 10th grade. We will use this equation with work because work has been done. It's a scalar quantity. Its unit is a joule. Okay? It is a scalar quantity for kinetic energy, and the unit is a joule. Remember, it's not a vector. As a vector, vector's got to have a direction. Scalar is just a number. So the work energy theorem, the work of a net external force is equal to the change in kinetic energy. So if we see this, the work energy theorem, the work of net external force, W is going to be equal to 1/2 mv squared. The final minus the initial. Okay, so it's just taking the final kinetic energy, subtracting it from the initial kinetic energy to give us that work theorem. There you are again. W equals KEF minus KEO. So if we were to do this problem, you're given a 0.075 kilogram arrow that is fired horizontally. The bowstring exerts a force on the arrow over a distance of 0.90 meters. The arrow leaves the bow at 40 meters per second, so therefore it's our initial. What average force does the bow apply to the arrow? So we're looking for the force here. You've got the mass. Remember, 1/2 mv squared. I've got the mass. The bowstring exerts a force on the arrow at a distance of 0.90 meters. I've got the distance. I know what we need for the distance when we talk about work equals force times distance. And I've got the velocity. So if I've got 1/2 mv squared, all I have to do is take to find what that force is going to be. When I plug that into my equation, and we can kind of talk about this one through our Zoom, I think it'll be a little bit easier because it's a little bit tougher problem. But you've got your mass, you've got your velocity, you know what it's going to be. Where do we find and what is that average force of that problem when you do that problem? Now, real quick, when you talk about that, one thing that I want you to think about here with this problem, as you do this, 0.075 kilogram arrows fired here horizontally, it goes a distance of 0.9, but the arrow leaves the bow at 40 meters per second. Now, initially though, the arrow was sitting still. It leaves at 40. So 0 is the initial. The final is going to be the 40. So if I take 0.075 and multiply that by 40, make sure I square the 40 because K equals 1/2 mv squared. Then subtract it from, obviously the next part's going to be 0, you're going to get your answer. So once you find what that kinetic energy is, you can find what the force is going to be because you'll know the work done and you'll know the distance. And like I said, I'd rather just do that one over Zoom. It'll be a lot easier to help you be able to answer that problem. So we're on the Zoom together as of now, and we should be able to talk together to be able to help us answer any of these questions that you guys might have. So if you got any questions for the Zoom, just make sure you ask me. Thanks.